Today we're going to be starting off with kinematics, the study of motion. All right, and let's see, kinematics. All right, so the first thing that we're going to be studying here is going to be distance. So since you know what the difference between a scalar and vector quantity is, this is basically what the entire chapter is going to be based on, or this is how you're going to be able to differentiate between a couple of things in this chapter, right? Now for distance over here, so distance is basically distance traveled by an object would basically be the length of the path that a person or an object has taken, right? So we're gonna write down a couple of pointers as we go. All right, so distance traveled by object, the length of path taken. Okay, now the SI unit for distance is going to be once again meters, because it's just a measure of length. Okay, and once again it is a scalar quantity. All right, why is it a scalar quantity? Because it only has the magnitude as in terms of how big or how small it is. All right, it does not tell you about the direction, which is why we're not going to categorize it under vectors. All right, now it can never be negative. Always remember this in questions, in MCQs or whatever you you're tested. Make sure to keep this in mind that distance is never a negative. All right, displacement can be negative, but distance can never be negative. All right, why? Because theoretically speaking, distance traveled just never decreases. All right, so yeah, distance would not be, what do you call it, negative. Okay. Okay, second. Sorry about that. Yeah. So that's basically what distance is. Now we're going to talk about displacement and compare the two after that. This. Now displacement is the same thing as distance. All right. The only difference is that displacement has a direction. All right. In other terms, you can also refer to displacement as the shortest distance between the initial and the final position of an object. All right. Or you could also say that it is distance in a straight line. All right. The rest of the things are the same. All right. The SI unit will be in meters, and yeah. So let's write that down. So for displacement is the shortest distance between the final position of an object. Okay, or in other words, you can say it is distance in a straight line. Okay, the SI unit will be meters. Okay, and it is a vector quantity. I forgot to write that over here. This one is only a scalar quantity. Okay, and displacement can be negative. Let me go ahead and explain to you that. Okay, Now let's differentiate between displacement and distance and what exactly is going on over here. So we got a point, say this is point A. Let's call this point B. This would be C, and let's say this is point D, or better. Okay. Now, it's very important for you to understand distance and displacement with the help of this diagram, because that's basically how you would distinguish it. So let's suppose if I'm traveling from B to C and from C to D. Okay, let's suppose if I'm standing over here at point B, I travel from B to C and then from C to D. Okay, this is my travel. Okay, this is going to be the distance I've traveled. But this is where I am right now. This is my initial position. This is my final position. This B over here is going to be my initial position, right? Now, if I talk about this in terms of the displacement, right? The displacement, once again, I told you, is the shortest distance between the starting and the final what do you call it, and the final position, right? The shortest distance, once again, always remember that it's always going to be in a straight line. All right, the same thing applies whenever you're taking a road, you always take a road which is going, just going straight, okay, to from one point to another point. All right, you wouldn't want to take small routes and try to take small streets and then go to a place. Why? Because that's a longer route. It always ends up taking you much more time and causing you to travel a greater distance, right? Now that is distance traveled, B, C, and C to D. All right. But if you talk about the displacement would be this. Okay. So BD is going to be your displacement, since that is the shortest distance between the two. Right? Makes sense? Do you understand what displacement and distance means so far?
Yeah.
Okay. Now, let's talk about how displacement can be zero. All right. This was this was acknowledging the difference displacement. Now let's talk about the other part. Let's say I'm traveling from B to C, C to D, and from D to B. Let me write that down. I'm from B to C, then I go to C to D, then from D to B. All right. This is basically what my distance traveled would be. All right. Why? Because let's recall, distance traveled is the total length of the path that we've taken. So when we're talking about the length, we're going to count this guy, we're going to count this length, and we're going to count this length. All right. When it comes to the distance. Okay. Let's talk about the displacement. Now, how exactly would we measure the displacement? The displacement, as I just told you, would be the shortest distance between the initial and the final position. Now, B is the initial position. What is the final position? It's gone back to B, right? Now, once again, if the initial and the final position is B, what does that mean? It means that your displacement is zero. In this case, your displacement is zero because there is no distance between the final and the initial position. Let's talk about another case where the displacement can also be negative. So what I'm doing is, now let's suppose I'm at point B. Okay. From B, I'm traveling to point A. Okay. Now, before we get into that, there's one thing that I'd want you to know. We call it the convention. Okay. Okay. So what exactly is the convention? Convention would be basically be agreed, an agreed law or an agreed key that we've set for ourselves, that it's basically like more of a standard that we have so that everyone's on the same page. So let's suppose if I'm moving forward, I would say that I'm moving in the positive direction. If I'm moving backwards, then I'd say that I'm moving in the negative direction. All right, same goes for people with a negative mentality. You'd say that they're always looking back in the past, right? You'd say that they have a negative personality, or they're being very negative. When somebody's optimistic, they're always looking forward to the future and what's coming ahead of them, right? So you call them positive and optimistic people, right? So the same thing is applied over here. This is the convention that we've set for ourselves in physics as well. So when something is moving up or something is moving towards the right, we call it, we call that a positive movement or positive motion, right? Something moves towards the left or something's going down, we call it negative. Make sense?
Yes.
Okay. Now, keeping the convention in mind, yeah. So keeping the convention in mind, if I am traveling from B to A, I'm definitely covering a distance. Now, is that distance going to be negative? Nope. I just told you, distance can never be negative, only displacement, right? This case, say that my displacement is negative because my object is traveling in the opposite direction. Okay?
Yes.
Okay. Now that we know what distance and displacement is, we know what the difference between them is. It's time to talk about speed and velocity, right? Now, just like we were differentiating between distance and displacement, speed and velocity are based on that. All right. So speed is basically the rate of change of distance, or the distance moved per unit time. Okay. The distance that you're covering in a certain amount of time, that's basically what speed is. Okay. Similarly, if you talk about velocity, velocity would be the rate of change of displacement, or the displacement per unit time. Okay, the only difference right we have over here is the direction. When you're talking about the speed, we don't care, or we're not concerned about the direction that's involved. We only care about the magnitude that we have. Okay. Okay. So yeah, speed and velocity. Speed, as I just told you, would be the rate of change of distance, all right, or the distance covered or moved per unit time. All right. Similarly, when we're talking about velocity, the only difference is the direction. That direction is there, then that changes the entire thing to velocity. Since when we're talking about distance, in distance we add the direction in it, that would make it displacement. And displacement upon time would be for velocity. All right, so let's write down a couple of things for speed first. Okay, so the distance moved per unit time. All right, so distance moved per unit time, or the rate of change of distance. All right, it's the same thing. To talk about the SI unit, it is going to be meters per second. Meters divided by seconds. Why? Because if you talk about the formula, that would be speed equals to distance upon time. Right? Now, is speed a scalar quantity or vector quantities? Speed is a scalar quantity. Why? Because it does not have any direction. All right, it only has a magnitude. All right, but I have a question for you. So if we have speed in a specified direction, what do you call it?
Velocity.
So there you go. That's about speed. What about average speed? Any idea? There you go. So the speed that we were just talking about above, that was instantaneous speed. All right, or the speed at a given point or a given instant, right? When we're talking about average speed is basically used to find out the average speed during the entire journey of of an object, right? So for average speed, what we do is we consider the total time and we take the total distance. Okay, so the formula, you don't really do anything to the formula, you just add total distance, you add all the distance that the car has covered, and you divide that by the total time it has taken to cover that distance. There you go, that's average speed. Okay, now if you talk about uniform speed, uniform speed would basically be when the object is moving at a constant speed, or the speed is uniform. All right, these are just other different words that we use for the same thing. Uniform means constant, constant means with the same intensity or the same magnitude, right? So let's suppose if I'm moving at a speed of 10 meters per second or 20 meters per second, let's suppose. If I continue to move at 20 meters per second for every single second that I move, right, then I would classify, or my speed would be categorized as uniform speed. Why? Because my speed is not changing. My speed is not changing at all, right? So it's a uniform speed would be if the object is moving with the speed, then the speed is uniform. There you go. What would be non-uniform speed? Any idea? So when the speed is not when we have non-uniform speed, we basically mean that speed is changing. It changes with time. Okay, so that means it is variable speed, in other words. Okay, so you can say that the speed of the object changes with time it's moving with, non-uniform or variable speed. There you go. So if we have a uniform speed, okay, let's talk about the graph in the end. Once we're sorted with speed and velocity and acceleration, all those things, then we'll talk about the graphs of all of them separately. Okay, so for velocity, as I just told you, is basically the same thing as speed. It's just basically speed in a specified direction, right? So we can write down a couple of things for velocity as well. Okay, so rate of change of displacement. Okay, or you could say that it is the change of displacement with respect to time. That is also true. Okay, the SI unit would be meters per second again. Okay, there's no change in the units because distance is also in meters and displacement is also in meters. Similarly, we talk about the quantity it's in, it's basically going to be a vector quantity. Why? Because it has direction to it. Okay, and once again, the formula remains the same. In place of speed, we can write velocity equals to, yeah. Now, since it's a vector quantity, you have to describe magnitude and you have to describe the direction when you're mentioning vector quantities as well. All right. Similarly, if you talk about average velocity, as I just told you, we talked about average speed. It's basically the velocity of the entire journey, the average velocity of the entire journey that the object had covered or traveled. Okay, so it says the average velocity, the entire formula remains the same. This just changes to total displacement upon total time. There you go. Okay, so that's basically it for velocity. Not much going on over here. Same thing, constant velocity means rate of change of displacement, but at a constant rate. Okay, so we have acceleration next up. all right, in acceleration, it's important for you to understand what acceleration is. Okay. Now, acceleration is kind of like the same thing as velocity and speed. I mean, the principle is the same in a way. Okay, because just like we have speed as the rate of change of distance, it's like we have velocity as the rate of change of displacement. Acceleration is the rate of change of velocity. Okay, is a change of velocity with respect of time. Okay, so there's a similar pattern that's being followed if you notice, right? So if you talk about acceleration, so let's see, so acceleration, if you talk about that guy here, we're going to write that it is a rate of change of velocity.
So does acceleration have a direction too?
Yes, and in the case of acceleration, since it's made up of velocity, that means yes, we're concerned with the direction the object is traveling in. Okay, which is why we're going to say that acceleration itself would be a vector quantity. Right now, the SI unit will now change. Why is it going to change? Let's talk about that. So the formula for acceleration is equals to velocity, okay, upon time. Okay. Now, change in velocity would basically mean the velocity that you were traveling with in the first instance, and the velocity that that you're finally traveling in, or the final velocity of your car or the object. Okay. Now, just like we had distance, just like we had speed describing the rate of change of distance, that means the amount of distance of the length that we were covering per unit time, which was seconds. All right, the distance that we were covering in a second. Acceleration would be the change in velocity, or the amount of change that we have in the velocity per second. Okay, so let's suppose if I'm traveling from 10 meters per second to 20 meters per second in 1 seconds, I would say that my change in velocity was of 10 meters per second, that too in one second. Okay, similarly, if I jump from 20 meters per second to 40 meters per second, let's write this thing down first. So let's suppose in at the first second I'm traveling at 20 meters per second. At 2 seconds, I'm traveling at 40 meters per second. At 3 seconds, I'm traveling at, let's say 100 meters per second. Okay. Now, in this case, my acceleration will be final velocity. Let me write that down as well. So it's going to be v minus u upon t as the formula. All right. So v over here stands for the final velocity, and u would be your initial velocity. Okay. Now, yeah. So what's the final velocity in these two cases? Final velocity will be 40. All right. My initial velocity that I started with would be 20. All right. So 40 minus 20 upon time. So how much is the total time that's taking me?
1 second.
Absolutely. So that would make my acceleration as 20 meters per second square. Now, why is it second square? Because this value is already in 20 meters per second. All right. I divided meters per second with another second, which meant, there you go. Do you understand why the SI unit of this guy would be meters per second square? Now let's talk about the first between 2 seconds and 3 seconds. Okay. In this case. So for this one, my final velocity, what do you think? So it's going to be 100 final minus 40 divided by 1 second, because this is the time interval. right? The difference of the time as well. So that would give you 60 meters per second square. That is my acceleration. Okay. So in the first case, in 1 second, the change in velocity that was observed was of 20 meters. In 1 second, I covered, or what do you call it? I speeded up, or my velocity changed to 20 meters per second. All right. And in the second case, in the second, a scenario that we have between 2 seconds and 3 seconds, my velocity took a major bump. All right. And in 1 second, once again, I jumped from 40 to 100. My acceleration was 60 meters per second. All right. Or 60 meters per second square. That my velocity changed from 60 meters per second in 1 second. Okay, makes sense. Now, in this case, you can visually see that, okay, I am speeding up, right? My velocity is increasing, all right, and so is my acceleration in this case. But what about a situation, a scenario when I am traveling at 100 meters per second at first, all right, and then from 100 meters per second, from, let's suppose if it's at 3 seconds, let's continue the same question, right? Now I'm traveling at maybe 60 meters per second, and that too at time 5 seconds, right? Now let's talk about the acceleration. All right, so what is the final acceleration over here? Okay, this is the final velocity. I'm sorry, not the final acceleration, final velocity. Yeah. So the final velocity is going to be 60. My initial velocity was 100. That comes over
minus
here.
40.
What's going to be 2? Why is it going to be 2? Because
5
that is
minus
the, yeah, is 5 minus 3 over here. That's the time interval between these 2 points. Okay. It's going to be 2. Now, if you subtract, you get negative 40 over 2. What does this mean? It means negative 20 meters per second square. Now, this is the point where you focus and grab your concept. This is called deceleration number 1. One thing that you need to notice, this is called deceleration or negative acceleration. Okay. Now, what's happening over here is that my speed, or my velocity is decreasing by 20 meters per second every second. Okay, so over here in this case, I've got 2 seconds to spare. All right, this is 2 second thing that I'm talking about. Now, in a time span of 2 seconds, I lost 40 meters per second in terms of my velocity. Why? Because my deceleration was negative 20 meters per second square. Okay, now whenever we're talking about acceleration, we'd say it's negative 20 meters per second square. All right, if you're saying it's deceleration, then you'd say it's 20 meters per second square, because deceleration means negative. All right, you wouldn't say that deceleration is negative 20 meters per second square. That would be wrong. All right, my acceleration is negative 20 meters per second square. My deceleration is 20 meters per second square, because it's obvious that deceleration is in the opposite direction, and you don't really have to mention the negative sign over that. After continuation of this thing that I've wrote down, if the velocity, you would say, if the decreases, it's going under, or it's undergoing deceleration. There you go. Okay, another example. Now, let's suppose at t5 seconds, I'm traveling at 60 meters per second. I'm traveling at 60 meters per second again at 5 seconds, or at 6 seconds, sorry. Traveling at 60 meters per second at 8 seconds again. Let's talk about this case now. So in this case, if we talk about the first part, what is my final velocity, guys? 60?
yes.
My initial velocity is 60, and the time taken is 1 second. This will be 0. In this case, my acceleration is 0 meter per second square. Why is it 0 meters per second square? Because there is no change in velocity to begin with. I'm traveling at the same velocity, right? So in this case, my acceleration is 0 meters per second square. Talk about the second case now. In the second case as well, if you notice, my velocity is the same, right? My velocity is the same. So it's 60 minus 60 again, final minus initial. And the time interval over here is 2 seconds. All right. So no matter how long I'm traveling, okay, if my velocity is not changing with the travel, right, with time, in that case, I would say the acceleration is 0. I am not accelerating. I might be moving, right? I am moving, but there is no acceleration. All right. Acceleration is 0. All right. The same thing, you can say that the acceleration can also be 0 if an object is at rest, okay, or if an object is moving with constant motion or constant velocity, okay. But if an object is not moving, if an object is stationary, 0 meters per second, t1 seconds, 0 meters per second, t5 seconds, let's suppose, my acceleration would be 0 minus 0, 1, let's say 4. Would give me 0 meters per second again, square. Okay, so these two, they're both similar situations. All right, and you need to remember that if I'm moving, if an object is moving with constant motion, or if it's in, if it's stationary, all right, there will be 0 acceleration. Make sense? If you want, you can write down a small statement over here. If the velocity, the object is constant, the for 0 acceleration is also 0.